This video will run through how to name some simple alkenes. Here's the simplest possible alkene, and as when we were naming alkanes, all we're looking for is the longest carbon chain. Here it's clearly just the two, and so this is ethene. And the next one in the series, we have a chain of 3, making this propene. Moving on to 4 carbons, we can have the carbons arranged like so, and the double bond is between the first and the second carbon, or it could be that the double bond is central and is between the second and the third carbon. So this is an example of position isomers and gives us but-1ene on the top and but-2ene below. Now with but-2ene, you might have also realised there's an alternative compound that we could have drawn due to the lack of rotation of the carbon-carbon double bond. We could arrange those 4 carbons like so. And this is an example of stereoisomerism, which will be covered later in this topic, and we need to refer to where these methyl groups are. So in the first example, those methyl groups are on the same side, so they are together. So this is the Z isomer, so this would be Z-but-2ene, the Z for zusammen, which means together, whereas on the right hand side those methyl groups are across from each other, so they are opposite, and this is the E isomer, so E-but-2ene, the E being for entgegen, which is opposite. More on this later. See if you can name this alkene. So we're looking for the longest carbon chain, including the double bond, gives us 5, and you can probably see that we've got 2 methyl groups on there as well. That means this must be carbon number 1, so that means that we're talking about pent-1ene, and so our methyl groups are on the 2nd and 4th carbon, which makes this 2,4-dimethyl pent-1ene. You will come across compounds which have more than one carbon-carbon double bond, so a diene with 2 or a triene with 3. In this case we have 2 double bonds, which makes this a diene. The same principles apply, so we're looking for the longest carbon chain involving those, so we have a chain of 4. So you'd probably think this would be but-diene, but we refer to it as buta, so it rolls into the D better, and then so the double bonds on the first and the third carbon in this case, so this is buta 1,3-diene.